So welcome back, and let's dive into our next session. Will be about Azure Site Recovery. So we covered the Azure backup and other things, storage related mostly, in our previous presentation. And this one will be more about how to keep things alive, how to have a continuous migration, how to have like a continuous life of application, how to benefit from cloud in availability topic, let's say. All right. So first of all, I would like to ask, what is your DR? What is your DR strategy? What is your DR plan? Like, how do you do it? Right now, you have like multiple locations, or
we replicate our VM to one
right. So you have like a two site and you replicate.
We have three sites.
Three sites. All right. Sounds good. Else?
Yeah, we have two data centers, primary and secondary.
All right. Same. Okay. Sounds pretty good. So usually when I bring this topic up, there's many different DR strategies. None of them is good, and usually there's something like the first one I kind of heard about that one. There's like ostrich DR. So they pretend there's nothing's happening, like there's no disaster, nothing can ever happen. This is the most common thing I usually see. The second most common is like this checkbox DR, like okay, got it, protected, and then want to test that thing. The plan B is I don't know, like I get cheap flight tickets, so I will schedule whatever it is and or search for a new job. So this is pretty much how DR works in most of organizations. These were the assignments, so I'm kind of glad that you have figured it out. But that could also lead to another type of DR, and that's let's say our mountain DR. So we have everything is covered. We have this and this and this, and everything is bulletproof. So we would like to avoid the third part as well, because we would like to test our DR. We would like to prove that it's capable with disaster recovery capabilities. We would like to test it several times per year, or even more often. And I will show you how to test your DR in Azure. I will show you how to prove that everything is working, how to have our test network and everything. So let's we will certainly cover all these. So you have many options for DR, and of course we will read these on the slides. So there are just a couple of companies with a smaller one that they don't just care about any DR. It's either too expensive or too hard to maintain or whatever. So they just don't care about any DR. So that's really certainly not good. But it's pretty common. Then it's like other common thing. There's a better DR thing, like usually backups offsite. You have some other solution. Couple of things you mentioned. You have secondary DC or other DC locations. You have active passive. That's a good thing. What we're gonna talk about today is cloud-based DR. Basically, I believe the most important part of it, like the best part of it, because cloud-based DRs are pay-as-you-go. You can provision your VMs only when you need it, pay for just what you need it. So you will just pay for storage. You will just pay for things you really use. So you don't need to pay for your secondary or other disaster recovery location just because you have VMware in it or something like that, just because you need to keep it alive, and you will do tests like twice or 3 times per year. How do you do test? How often do you do test? Tell me. How do you test it?
At the DR side.
Yeah, on the DR side. How often do you test your DR side per year? So you have anyone else? Okay. So you usually have this live site with working hardware and everything. You paid for your licenses. You need to renew them. You need to pay maintenance for them, and you use it like once or twice per year. So that's what we are trying to avoid. That's why I would like to introduce the cloud backup for you, because they will have this pay-as-you-go model and pay for everything, just for what you use. So what you need DR for is for any case failure. So it doesn't have to be something huge like fire or I don't know, broken data center or whatever. It usually it's something small. It's something small, some small thing that can affect your systems. Usually it's something like wrong update for .NET, which Tuesday goes wrong, and there's a there's like a mild network outage or storage outage. That's just one element or just few of them. There's some misconfiguration, power outage. Usually this misconfiguration is caused by a human, and based on statistics, about 60% of all DR events are caused by human error. Usually someone types something wrong in the console or in the PowerShell, and suddenly you have something wrong. And this is a pretty common thing. It happens to all of us. There was a POC for Azure. I did for one of my customers in my previous company. The company was like a huge meat supplier for supermarkets, and they decided to open their own fast food network. So they started with these fast foods, and they need some backend systems for their sales points, count every order and everything. So we went through this POC. These guys were really, really silent. I asked every week if they need anything, if they need to explain how these things works, like during a regular POC. They never replied. So after the POC, after 1 month, I decided that if they were so silent, I would just like to shut down the VM POC. It's over, and we can move on. It was just one VM. So that's also not good for DR. If you have just single node for all of your every component of your system, you have a single point of failure like they did, it's not good, but you probably know the thing. So I just decided to shut down the VM and write an email. Hey guys, thank you for a POC. POC is over now. You will validate it with your sales guy. And they quickly replied. I never seen a reply so quick before. Oh, come on, don't shut it down. There's all our sales points are hooked up to that database. Okay, so you are telling me that I knocked out your main database? Yes. So this is how DR happens. So it's caused by human error. This was like on all of us because they didn't tell me that they turned the POC to production. I didn't tell them I'm about to shut it down, but this is how it can happen. And it's sad and bad to have a single point of failure like that. So this is how it happens. So we are trying to avoid these things, and I will show you how we can actually have a DR strategy for things like that. So business needs to need some continuity. Every app that you have needs some continuity. I don't know if you have specified SLAs for all of your apps, but there's always some blockage in this business continuity. So we'll try to eliminate these blockages with cloud, and let's see how we can do it. So we have a complex environment. We need to protect our data and applications, or we have too much of data, and it would take too long to replicate these things. So let's go for individual things and try to solve it with cloud. So for complexity, we have a solution in automation. So it doesn't matter how complex your environment is, we can always automate that thing. We can automate that recovery. So I worked with my previous customer. They maintained high voltage wires, and they had this portal. So the portal was really critical because all the power stations and everything, just they depend on actual data on this portal. So everything needs to be there. It consists from SharePoint, from Pistol, some front ends. All these components need to be started in proper order. And there was some change of DNS records, failover. There were other things like changing of addresses and checking the databases. These steps are, for all these steps, it's possible to have some automation. So we can automate this thing, and later I will show you some recovery plans. If you have too much of data, oops. Sorry for it. If you have too much of data, you can always use things that we talked about, like during the Azure backup thing. You can schedule an import and export job. So, and you can scale this solution based on individual blocks. So it's not the block for us. You can always have some solution for how to get your data to cloud, or at least part of it, and then migrate just the difference, or how to solve these things with Azure Backup, Azure Storage, and Azure Site Recovery. If you have longer attention requirements, actually we saw in previous presentation that's not a block for us, because cloud is scalable thing. We don't have any pre-provisioned capacity. We don't need to pay for any pre-provisioned capacity. We pay for what just we use. So if we have anything long term, if we need anything to store for a very, very long time, you can always pay for what just we use and nothing else. Cloud also solves the problem with time and replica for different type of media, because cloud actually doesn't use any of those things. There's a prepared solution for all of you. There's a prepared solution that many others tried before you, so you can benefit from their experience, and the solution is already prepared for you, so you don't need to build anything on your own. Regarding testing and test DR environments, we would like to avoid untested DR. So Azure Site Recovery is testable. You can test your failover without affecting your primary site. So if you would like to just try if your VMs are properly replicated, you can always do that with Azure Site Recovery. You can always have your test network. You can always just hit the button and try the test failover, and then clean up the environment after you. It will have no effect on your primary site. So you can always have like an isolated network and test it. You will pay just for the runtime during the test and nothing else. It's standard capability of Azure Site Recovery. And regarding to the cost, of course, the site recovery locations are pretty pricey. So with cloud, we can solve these things with payment for just what we are using, as pay as you go. So it's a thing we covered many times. Azure Site Recovery have two main price tags, and that's a storage, and that's a protection for per VM. So you pay monthly protection per VM, and just use storage. There's a third price tag, and it's only in case of disaster recovery, and that's the runtime of individual VMs. So based on this VM profile, based on their size, based on their CPUs, based on the amount of RAM they need, we will pay for the runtime of the VM. So we will pay just in case of disaster. Everything else is just like a small static payment. The major one comes only in case of disaster. So you can test it and see if everything's okay, and there is no other cost adequate. So about site recovery, covered it a little bit in previous slides. Azure Site Recovery is a huge scalable service based on Azure VMs that can contribute to your disaster recovery strategy. It can solve your disaster recovery problems. So since in Azure there's a huge amount of hypervisors, they already run thousands and thousands of VMs, hundreds of thousands, millions of VMs, you can use it for just replicating or receive the replica of your own VMs and add just a couple of them. So you can always use this power for scalable disaster recovery, and I will show you a couple of scenarios how you can use it. There are also huge storages already prepared. We talked about storages, we talked about storage accounts. You can use this storage account to receive your data and recover your VMs from it. So in upcoming slide, we will cover everything about Azure Site Recovery. The main advantage of here is that this solution is cost effective. Like I mentioned 1,000 times, you pay for just what you use. You can replicate complex environment. It doesn't matter what you have. You can have multiple things. You can have Hyper-V, you can have VMware, you can have physical machine. You can replicate all of them. There's no limitation on the functionality you can use for all of these scenarios. So even if your machines are running on VMware, or they are physical, or they are on Hyper-V, Hyper-V standalone, Hyper-V with System Center, all these scenarios are for you. Site recovery offers you continuous data protection because it will replicate every increment to memory that you have. So you have your working machine runs, do the normal thing, and you will have every increment counted as a replica to your Azure Site Recovery solution. So in static interval that you can set up, from 30 seconds to 15 minutes, you can receive increments of memory. And all of these increments will be counted and added to your replicated solution. You can recover from these recovery points and create this VM. So if there's any failover, and you actually need to failover to Azure, with this difference, like 30 seconds up to 15 minutes, you can have your environment back. So there will be any difference like for just the time when the VM actually starts, and then there's this time difference from the last replica. This could be your difference in the recovery. Azure, of course, supports many types of networking, so you can have your prepared internal IP addresses for your VMs. You can have your public IP addresses. Azure also offers many things around DNS. So there's Azure DNS globally available since this Ignite. So you can, if you store your DNS records in Azure, Azure DNS can actually write these DNS records pretty fast, very quickly. You probably have you ever used Azure Virtual Machines? Try it? Yeah? Great. So you probably noticed that if you start Azure Virtual Machine, if you don't have reserved IP address, you have randomly assigned public IP address. And there's always DNS name. So how the DNS name changes so quickly? You can always immediately connect to the DNS name, even if the IP address would change like a minute ago. So that's the power of Azure DNS. You don't need to wait for a replica of your all DNS servers across your organization. Azure DNS pushes that thing immediately. So if you have some critical application and you don't want to play with TTL on DNS records, you can use Azure DNS. And Azure DNS basically pushes this record through all of Azure regions, and from these regions to responsible DNS servers that are cloud-bound. So you can have really quickly replicate your DNS records in case of disaster recovery.
And it's scriptable. So
then we need to basically prepare our infrastructure for Azure Site Recovery and monitor it out. And that's there's a thing called Azure Site Recovery Vault that will help us with that. So we have many different workloads how to work with Azure Site Recovery. So these two primary workloads are for on-premise solution. We have many for cloud solution. So if you don't want to migrate anything to Azure, or you can't because of regulatory requirements or whatever, you can still use Azure for orchestration or improvement of your current disaster recovery solution. So you probably have two sites, like you mentioned, and you have other channels for replicating everything. You have something for storage, you are using Hyper-V replica, or you are using VMware, what's called on VMware as vMotion. All right, so you are using this for receiving the actual replicas for primary location to your secondary location. But you don't have, probably you don't have, correct me if I'm wrong, you will probably have this automated solution for recovery. So if there's an actual failover, you need to do things manually. We did it for our customers previously, my previous company, for this administrator of high voltage wires, like I mentioned. We had like a spreadsheet, thick like that, with all the checkpoints that we need to do to check if infrastructure is properly replicated and to test it. So we had an order for starts, like first you need to start domain controllers, of course. Then you need to start SQL. Then you need to start actual application. You need to check if load balancers are okay. You need to check DNS records. You need to check changes of addresses. And all these things can be automated with Azure Site Recovery plans. So Azure Site Recovery is there and watching your primary location. If there's any fail and you need to fail over to the secondary location, Azure Site Recovery is capable of noticing it and does the failover for you and actually runs the automatic recovery plan for you. So you don't need to do anything else. You just wait for it, wait for a couple of scripts that you have prepared, and this is how you can improve your classic on-premise recovery strategy. It works on Windows Server with Hyper-V and with System Center with VMM, Virtual Machine Manager. Also work with VMM, with VMware, and with vSphere. You can use both of these scenarios. Both are generally available, both are available for you. For better type of strategy, you can avoid to have pricey secondary location. You can have secondary location in Azure. So you can actually replicate these things, all the VMs, all the VM increments, everything related. You can actually replicate them to Azure and force Azure hypervisors to receive this replica, this technology. So you have your VMs stored in Azure storage, and if you need them, if you need to spin up the VMs, you can actually use Azure VMs for this technology. Azure Site Recovery will take care of it. You have this automated recovery plan for every automation of your solution that I mentioned before. So if you had automated solution before, you can use it here as well. Again, it works for Windows Server standalone with Hyper-V. It works for Windows Server with VMM, System Center. And it also works from VMware for VMware and datacentre. So you can actually move or migrate or replicate your current VMware infrastructure directly to Azure. Let's see how it happens. Okay, let's check the details. This pretty much was what happened in Azure before. I will go a little bit back to the history, because when they actually introduced this thing, when they introduced the preview for VMware Replica, it was on one of our calls that we had with the product group, via MVPs. I was really surprised because I've been to Dublin data center. I've seen every hypervisor there, and all of them are Hyper-V based. It's pretty much similar to Hyper-V, but VMware was something kind of new. So I asked, guys, do you seriously run new like VMware hypervisors in your data centers? Or how do you do it? They said, no VMware hypervisors, we convert the replicas. Every replica is converted. So their approach back in the time was to use a process server. So there's a VM which sits in your location that you need to add. Actually, if you have VMware, you need to add this VM to your current infrastructure, and this VM actually stores all the replicas on premise. So it's like a cache point. On these VMs or all these hypervisors, there's a thing called mobility service, which collects all the data and actually stores them on the process server. So process server is just for this heavy lifting. You don't actually want your VMs or your hypervisors to lift all the VMs and care of the replica, because you would need to adjust the performance for these VMs. So the process server is for this thing. So you will just do your homework and prepare process server for this heavy lifting, and they will do the rest for it. So process server is there for sending the cached replica to Azure Site Recovery. It doesn't need to cache all of your infrastructure, so you'll need some huge VM. It needs to cache only part of it before it's sent to Azure. And there's also compression, so you can compress these things to 30%. So in Azure, there used to be a thing called master target server for receiving of this replica, and there was a config server for centralized management of it. So master target server actually stored all of these replicas. So that's how you could actually recover all your infrastructure. This model, of course, was still kind of pricey, because you needed to run this part in Azure. It needed to run all the time. So you need to have a couple of VMs, like really huge VMs, for receiving just receiving replicas from process server and just for storing them. So this was kind of a pricey solution, and Microsoft decided to improve it. The current state looks like this. You still have mobility service, which actually collects your data from your hypervisors from individual ESXi hosts. You still have your process server because you need to cache these things somewhere. But the actual converting is managed by backend in the Azure. So you don't need to have these VMs there anymore. You have just this. So the moment you create Azure Site Recovery Vault, there is nothing else you need to do or nothing else you need to implement in Azure. You will just implement this process server, and process server will start to replicate these things in Azure immediately. So there's nothing else you need to do. There's no other VM. There's no other cost like on the previous slide. This is current and improved mode that you have. So if someone presented site recovery from VMware for you like 6 months ago or whatever time it was, and totally it's kind of expensive, now it isn't. This is the solution that we have now. You don't need to have any other infrastructure for connecting your replicas. It's all taken care of. Microsoft will do it for you. So the process server is something that you actually need to deploy on premise. We don't for VMware things. For Hyper-V and for VMM, there are much easier prerequisites. For VMware, let's take a look at it. So you don't need master target server and the config server anymore. You just need the process server on premise. So this could be like a tiny, not exactly tiny, but a medium VM on your own infrastructure. It needs to run Windows Server 2012 R2 at the minimum, and it must be at the same network as your other VMs because it will receive the replicas from the mobility service. So you actually need to have this somewhere visible on the network. You need to plan CPU and storage consumption for this server because, of course, it will cache every information that will fly through it. So if you will start a replica of your servers, it will cache initiated replica, and then it will send to Azure. So you kind of need to prepare for it. For Hyper-V, there are much easier requirements. If you have System Center, you can use Virtual Machine Manager, and there are only two things that you need to do. Install agent on the VMN and install agent on individual Hyper-V hosts. Agent on VMN will actually take care with DR orchestration. Yeah? So actually the agent on VMN will receive every information from Azure Site Recovery. It will inform Site Recovery about current state of replicas. It will inform it about recovery plans. And it will receive this information back again. Okay? On actual hypervisors, you will have this agent, which is really, really similar to thing we saw for Azure Backup, because it's just an agent capable of sending data across network to your Azure Site Recovery Vault. So this agent will actually take care of the actual replica. Both of these things could be behind the firewall. You don't need to set up anything specific for it. You just need to have open port for free and allow specific addresses if you have that specialized focused firewall. So this is the easiest way how you can implement this thing, because for Hyper-V you don't need any conversion, you don't need anything else. If you have individual Hyper-V hosts without VMM, just imagine there's only this part, like just this replica. So nothing else there, you don't need to take care of it. So this is the thing for the prereqs for Hyper-V and individual Hyper-V hosts and the VMM. We'll take a look on it, how it looks like. I have my VMM here, and I have Azure Portal. So for start, let's take a look on Azure Portal again. So this is my Azure Portal, and I have pinned my Site Recovery Vault here. So again, we can see my Site Recovery Vault, and this is the exactly same vault we used for Azure Backup. It's the same management. We have these things unified under the same management, and you can use it together. So in this vault, you can actually see much more information. We're actually using some of the backup for our production environment, and we have one replicated VM for testing. So we can take a look on that recovery replica VM, and there's a VM with this name, and it says it's protected. So if I take a look on that, there's actually a prepared plan for it. If I will start this VM in Azure, it will be started in the target size of basic A2 VM, which is like really a small VM. You can plan this for individual VM. You can have individual hardware profiles for individual VM in case of failover. So you don't need to plan it when it happens. You just need to plan before, and they will start with the appropriate count of CPUs, appropriate count of RAM. Okay. So another thing we have is targeted network. So we can specify many different networks that we can specify. We can have this recovery for. So if you would like to recover these to the test network or production network, you can always have the specification here. And we can also check if all the disks are in places. We have just replication for this for main disk for C drive. Then we have this network mapping. So if I would like to change it, if I would like to change the network or change the size to something else, I can select the appropriate value here. There's a variety of many different sizes. In Azure, you have many different instances with different types of CPUs. So you have Intel there, you have AMD there. There's many more generations of Intel. So these are with like previous generation of Intel Xeon. The V2 is a current version of Intel Xeon. So you can actually use these things and customize it as much as you want. For target network, I can actually select the target network here. So I have just this production one. I can select specific subnet there, so I have my front-end subnet for servers. If I would like to assign any specific IP to this VM, I can do it here. So for example, for your IIS servers or something else, you would like to have your specific IP for something else maybe. So this is the basic setup I need to do, and there are these important buttons. So I can always run planned on unplanned failover, and I can also run my test failover. Test failover creates just independent environment. It will just create a copy of my VM based on latest replica. I will show you that. I will not press it because I don't have access to the actual VM, so I can't prove it's up. But you can actually select your virtual network here once again, and here you can select from a list of your Azure networks. So you can build networks in a completely separate way, and you can completely separate the network somewhere else in Azure. It will not be connected to your on-premise, so there will be no effect for your VMs. And you can just test the thing, and after you are done, this is completed, and Azure will automatically clean up the environment for you. So this thing won't affect your on-premise infrastructure. For planned or unplanned failover, there's actual effect on your infrastructure. For planned failover, Azure Site Recovery will actually try to shut down your VMs on-premise if it can, actually. If you have a network outage, obviously the Site Recovery won't see any of its agent and can't shut down the actual VM, but it certainly will try it. So don't use this as a test. Always use the test failover for it, because this thing will certainly try to shut down your VMs. Unplanned failover works in a similar way, but basically you just want to fail over the VMs. You probably want to trigger this automatically or manually. It's up to you, and that's in the worst case scenario that you really need to fail over. You didn't plan for it. You just have some outage that you didn't expect. Okay, so in VMM, I have my clouds, and we have many clouds here. So you can set up protection for individual clouds. You have this button, Manage Protection here. So you can turn these things individually for individual VM, and you can set up these VMs to replicate to Azure in a selected frequency. So I will show that on a cloud that we actually use here. This is our production cloud, and in properties I have just one thing that appeared after installation of the agent. there's a send information about data to site recovery. So in this way, I have my cloud protected, and I can select individual VMs to replicate to Azure Site Recovery. So for failover, for basic guidance, if you have some planned failover, you want to shut down your VM first. Then you do the failover, because otherwise the site recovery will try to shut it down for you. And it triggers the recovery plan. So in the recovery plan, you can have everything I mentioned scripted and automated. You can use Azure automation for it, and you can change the name, the IP addresses for the servers, change the DNS record, start servers in appropriate order. Or if you don't have any script, there could be just wait action for manual input of one of your technicians. If there's any manual input that you need, there's just a timeout that you can set up. So it could be automatical, could be automated easily, could be manual, however you want it. And if you test it, there's a failback. So if you actually fixed your on-premise location and you need to fail back, it works in a way that it checks for difference in your Azure side and for the latest update that you have for on-premise. That syncs back the difference and then starts the VMs on-premise again and shut down the Azure, of course. For test failover, it's pretty simple. You just test the recovery plan. It don't touch the thing doesn't touch the VM on-premise. So you can just test your recovery plan, test if everything is okay. You can test your app in isolated network without any breach, or if you want, you can have actually set a VPN to your network on-premise to check if there's a, I don't know, maybe reference to the database, if there's a proper connection string, whatever you like. You can, if you would like to test any client's application, you can actually spin up a tiny VM in the same network in Azure, and you can check the client side from there. It will be much easier than try to connect it back to on-premise. It might be better and safer for you. And after you are done, Azure automatically shut down the servers and clean the environment after you. So it will delete all the VMs. It will keep the storage, of course, but it will delete the VMs, and it waits for another failover. So I talked about changing of DNS records, and there's another thing you can actually do. One of the things that you can use is Azure DNS. And you can store DNS records there, like public DNS records. But there's, of course, another thing that's for like continuous availability. You can use technology called Azure Traffic Manager. And it works in a way that you have your client, and client access some DNS. The DNS actually is the DNS of the Traffic Manager. And Traffic Manager routes your connection to your primary site. You can set up failover mode, and if there's a longer time to live that Traffic Manager can reach, if Traffic Manager actually decides that your primary location is down, then the Traffic Manager redirects automatically your connection to your secondary location, automatically recovered in Azure. So if you have any failover, you probably triggered or even triggered your site recovery plan, and you have your infrastructure recovered in Azure. And Traffic Manager knows the new DNS and automatically redirects the traffic for you. So this is a thing for continuous availability. You can also use Traffic Manager for other things. There's a performance, for example, mode. There's a performance mode is for it redirects your client to the closest location. So you can use combination of Azure data centers, of on-premise data centers. You can combine these things to redirect your client to the closest one. You have this failover mode, and that's how Traffic Manager works. So you can benefit from another technology in Azure, which is really, really cheap, and you can use it that way. So that actually is my last slide. So do you have any questions? Everything clear? All right.